Kali ini kita akan mempelajari mengenai fundamental frequency estimation method.
In this chapter, we will learn about three things. First is influence coefficient method, next is fundamental frequency, and how to find natural frequency using Dunkerley's equation and Rayleigh method. Influence coefficient will be divided into two methods, which is stiffness influence coefficient and flexibility influence coefficient. Stiffness influence coefficient. K is the stiffness metric and the element of stiffness metric are called stiffness influence coefficient. K can be written as Kij is defined as force at I with displacement at J. For the example, from the figure, we have 2 degrees of freedom system. We need to find the stiffness influence coefficient. The K will be in the metric form and we have, due to 2 degrees of freedom system, so this metric will be 2 times 2 metric. Apply unit displacement at mass 1. This is the free body diagram for mass 1. From the free body diagram, we can get the equation of motion. Then, apply unit displacement at mass 2. This is the free body diagram for mass 2, and from this you can get the equation of motion. Rewrite the influence coefficient. And the stiffness metric we got flexibility coefficient. This is the equation that is used for the multi-degree of freedom for undamped, which is M is a mass metric and K is stiffness metric. Flexibility metric. The A will be written in a metric form. Aij is a deflection at I due to a unit load applied at J, while Aji is a deflection at J due to a unit load applied at I. Aij is equal to Aji. For the example, the A formula can be written as for case 1, the unit load will be at M1 where M1 is equal to 1. We need to draw the free body diagram and write the equation based on the free body diagram. For mass 1, the equation is, for the second mass, the equation is, from equation 2, from equation 1, we will get the first influence coefficient A11 is equal to 1 over K1. From equation 2, we will get the second influence coefficient A21 is equal to 1K1. For case 2, the unit load will be at M2 where M2 is equal to 1. Next, we need to draw the free body diagram and write the equation based on the free body diagram. For the first mass, the equation is, then for the second mass, the equation is, from equation 1, we will get the first influence coefficient A12 is equal to 1 over K1. A12 will be substituted into equation 2 and we will get the second influence coefficient A22 is equal to K1 plus K2 over K1 over K2. Then insert our value into the formula. And we got this flexibility influence coefficient equal to Dunkerley's method. First, it used to find natural frequency of multi-degree of freedom system. Next, enable us to get a reasonable good estimate of the fundamental frequency of multi-degree of freedom system. Higher natural frequencies of most vibratory systems are large compared to their fundamental frequencies. The formula can be written as below. The formula are written in metric form. After further simplification of equation, we will get this equation is called Dunkerley's formula. This is an example of Dunkerley's method. For the first step, we need to find the flexibility influence coefficient first by using beam deflection formula. For case 1, F1 is equal to 1 and F2 is equal to 0. This is the beam deflection formula. For case 2, F1 is equal to 0 and F2 is equal to 1. Based on the Dunkerley's formula, it can be said that for value of A11 and A22 is the same based on both cases, which is Rayleigh method. Rayleigh principle. The frequency of vibration of a conservative system vibrating above an equilibrium position has a stationary value in the neighborhood of a natural mode. This stationary value is a minimum value in the fundamental natural mode. Derivation. It is based on energy conservation theorem. The kinetic and potential energy of n degree of freedom discrete system can be expressed as, to find natural frequencies, we assume harmonic motion to be where x is the mode shape or amplitude and w is the natural frequency. If the system is conservative, the maximum kinetic energy is equal to the maximum potential energy. Tmax is equal to Vmax, thus we obtain the frequency term as equation 6 is known as Rayleigh quotient and is denoted as Rx.
Terima kasih kerana menonton.